I don't know why.
Half minutes to go.
For the Thursday stuff. So.
Yeah, I have full agenda for Thursday and also Wednesday, and I leave Thursday afternoon. I have been here since last Wednesday, so yeah, it's already too long for me.
Consumption or also production of those working groups?
There was a workshop last week. Okay. We had with a bunch of Canadian professors. Yeah, that's quite good. Yeah. Could you bring up the church lights, then we can start?
Yep.
So that's 10 o'clock.
This is not compliant with people with glasses.
Yeah, both of us.
Well, you're not 50 yet, so at that age, the eyes start.
Almost. The 10 years don't make that much different. I already feel my eyesight get fit. Okay, it's 10 o'clock. So somebody at the back could close the door. All right. Thank you, Brian. Yeah, welcome all of you. This is the ANIMA working group, Autonomic Networking Integrated Model and Approach. So if you're hanging in the wrong room, still have time to get out. Next page. I can.
Clicking buttons and they're.
Oh, that's through responsible. So this is a note wheel. I guess all of you should already see it several times this week. So, but that's still what you should behave according to the IETF. Everybody should pay attention. Yeah, we hand over the blue sheets around. Make sure you're signed before you leave the room. And we need job scriber. Anybody volunteer for it? Jabber, thank you, Michael. And we need minutes taker. Anybody volunteer? Thanks, Bing. You're always so nice, both of you. And we have the remote participation online, and all the slides already uploaded online, so people can check it even afterwards. And the mailing list is ANIMA IETF. Oh, that's a mistake. I should put IETF there somehow. That's basically the mailing list is one of the official working place. People should make discussion there, and actually, the chairs will, make some information out of the mailing list discussing, and the face-to-face meeting here is just, basically use our time here will based on what we already make the congestion makes the discussing on the mailing list, and this is chaired by me, Xin, and Terry's Ecker. Okay, this is the minutes agenda. We have working group dash, and we have the working group document update. For this time, we applied 2 sessions. So the morning session is for the almost everything, but Brisky relevant stuff. So the afternoon session, we have 90 minutes, that's for Brisky. And we should go first for the working group document. We have ACP Autonomic Control Plan update and GRASP API update. Then we give the progress report on our rechartering progress batch here. Then I actually moved the last item, the autonomic setup of fork monitoring agent to the just after the recharter report. That's because Carlos here has to leave earlier for another working group. Hopefully the other speakers don't complain about this. Then we have the information distribution and the guidance for ASA and transfer back data over GRASP. Then we have the scenario and requirements for layer 2 ACP, all done by Brian. Okay, this is the agenda for the morning. Anybody has any issue on it? Once, twice, go. This is the agenda for the afternoon. We have all the Brisky relevant drafts, including Brisky itself for update, and also the constraint voucher update. Two of them are working group draft already. And we have constraint joint proxy for Brisky protocols. Peter, I didn't have your slides yet. No, somehow you said it. Please do send it again. Thank you. And we have support of asynchronous enrollment in Brisky, and the ACME integrate with Brisky. That session starts this afternoon, 1:30. Okay. Given the last 4 years, the working group already produced only 2 RFCs, but we actually finished 5 documents. Another 3 is sitting in the rack for the misref, but hopefully we have the CDDL Kuber already in the RFC queue, I believe. And the ACP, we hope to finish it this meeting and get it in the IST before. Oh, that's already in IST. But yeah. Hopefully we will have those in within this year to be RFC. Then that means we can have at least 4 RFCs completed in this year. Oh, that's good. We have the ACP draft already in ISG. Still has to discuss. Hopefully that would be resolved very soon. And we have Brisky, another round reversed ID needed. We'll see according to the update this afternoon whether we need another working group last call or not. And we have the GRASP API, which will make an update this morning, and the constraint voucher update this afternoon. And let's say some extra information. Managed next meeting in Singapore. Okay, so here we go for the first presentation. That's should be you, right? Where it? Okay. As normal, the working group draft has a priority, so don't be surprised if the working group draft report take longer time than we planned. We actually have, should have sufficient time this meeting. Up to now, we have 15 minutes spare time. Use it. Will.
Oh, good morning, everybody.
Closer?
This one.
No. Mike. It's same time.
Okay, so we've got the dwarf microphone. Okay, I hate this. Sorry for that. Okay, so this is, I forgot to update the number. So this is the update for ACP since IETF 104. In 104, we had version 19. And that basically had the answers to the security ISG review from Ben Kaduk and Eric Rescaller. And effectively, I didn't receive replies for that since last week, and since then I've been working to get /20 posted, which I did yesterday. And the reason was that the reviews, it's a very large document, right? So basically, what we miss a number of documents, we have a number of pages between Brewski and ACP document. And effectively, one AD had to stand in for two ADs because Eric Rescaller's term expired also between 104 and 105. So basically, Ben had to jump into the existing review from Eric and take it over. And so he did an excellent job with a lot of details. So that was a lot of work. He was also moving. So that was basically why it took the 3 months between 104 and 105 to get all the feedback that was done at the IETF 104 with 19 into, back to me last week, and I refed it now. So there is also kind of the oversight somewhere between me and Alyssa in terms of Alyssa's feedback is the only other outstanding discuss on the IESG. And that was actually closed in August last year, in my opinion, with a reply and review. And I checked, and there was no other reply from that. So I sent a reminder yesterday as well to basically see if he also thinks that her review and the Gennard review from Elwin is closed. But I think that is all not really critical and should be very quick to do. And then also, this whole GitHub stuff, I really don't live that. So I discovered very nice things that Michael had proposed in January, and I also pulled those in. So in summary, I think the outstanding issues are to discuss from Ben. One is about the encoding of the ACP domain information in the certificate. And the second one is about details of the security profiles of the different protocols. And that's what we're going to talk about in the end of the presentation. I quickly wanted to go through the changes that were done between 19 and 20 that I hope are uncontentious, but interesting, and not the 100 others that are uncontentious and non-interesting. So I reworked and improved the ACP domain membership check text because it seemed to been unclear whether this is something that should only rely on certificate encoding, which is defined in RFC 5280, but rather it really depends on each individual association protocol because it depends on proof of ownership, which is a process done by the security association protocol. So that's basically referred to. There is more specific reference to the certificate chain verification, which is actually defined in 5280 when there are certificate chains. There was in /19 in the IETF 104 review also the point about stapling. So those things are hopefully now covered correctly, saying that when only when the security association protocol is too weak so that you cannot do, CRL OSCSP with itself, then we can skip during the security association CRL verification OCSP and basically do it later on when we get it. So, and then there's a new summary at the end of the section to restate the individual purpose with respect to authentication authorization for each of these six steps. So I'm not going to go into detail on those. For the certificate renewal, we are mandating the EST protocol, RFC 7030. And there's basically the interesting problem of why do we need actually, to be able to identify the EST server as a valid EST server? And if so, how do we do it? So 7030 was asking to do this by having EST servers have the ID KP-CMC-RA extended attribute in the certificate. And so that is also now required here for EST servers in the ACP. There was no good explanation given why, under which circumstances that actually helps, as opposed to just having normal ACP certificate. And so the justification that I put in there is that this is primarily the way I understand it, and that would be good if security experts would chime in and tell me if it's wrong. I hope it's not. That if you're actually renewing the trust anchors, you really want to know that whoever gives you the trust anchors is something more than the random note in the ACP, but that is actually somebody who is a trusted part of the security chain, meaning a real registrar that has the authentication from the CA. Because in the certificate renewal case, you would already be able to figure out that it's an attacker because he can't even give you a correct rekeyed certificate. So that was basically those key parts. If you want to comment, please. I mean, that's what we're here for. It's called working group, not presentation group.
Michael Richardson. The extended key use stuff in my mind is in general make work for lawyers, but because people that check it are compliant implementations, and people that don't check it can do whatever they want, and they can always do whatever they want, and the legal stuff won't change whether they do it or not, and putting the bit there won't change whether they do it or not. But the intention of the CMCRA is, I think that you did get it right. It's so that you know that you are speaking to a representative who can actually enroll you in that specific CA.
Well, this is not enrollment, right? This is all only renewal.
Renewal.
Yeah.
But renewal is it will re-enroll you in that specific thing.
Yeah.
I don't really understand what the attack it prevents. I'm not sure there is one.
Well, I'm the random.
But that's what RFC 7030 says.
Right.
You will have that, and 5280 says something about it, I think, too. And thus you have it. It's a bit annoying because it's not, if you are using OpenSSL, it's not one of the IDs which is predefined. I've had to add it, and it's added in a way that you need a source code update to do it. So it is annoying,
Right.
But that's what the spec says, and it seems, oh well.
Right. Well, I mean,
I haven't written any code to check if it's there.
Yeah. Well, I think the attack is,
right? So I just consider it busy work, right?
Well, I mean, I think the attack is that at some point in time, a client figures out that the trust anchor certificates are expiring, so he's renewing the trust anchors. And if then he gets randomly to some attacking EST server on the ACP, some, sitting nowhere IoT device that has been intruded, how do you prohibit that?
You can't do that without a CA being, without the CA. The attacker has to be a compromised device that's already enrolled in the CA.
Yes.
Okay. So, and has compromised the network and is
Right.
now pretending to has an identity that matches the something. So it requires a bunch of things, and I'm not sure that bit actually helps you.
I think it only requires you to be able to upload some application software that, looks like an EST server to such a compromised IoT device. The device already has an ACP certificate, and that's all it needs, right? There is no further verification possibilities on, I think.
It has to be a compromised IoT device. I think it's a
Oh, okay,
compromised
non-IoT device.
ACP, right?
That's fine.
But
Well, because I would also,
I don't know how it solves the problem, but 7030 says you shall set this.
Yeah,
bit,
exactly. So
we should set this bit. Right?
well, I was trying to come up with the best possible explanation why it really makes sense to add exactly that type of code that you were saying. So, and if that's actually, if nobody can come up with a good reason, I'd rather, go against what, the ISG review said and stick to simpler software. But basically, we'll need to be sure that really it is not clear that there is actually any attack vector that it prevents. Okay, so, right, so what else did we have? So serve EST grasp objective. Michael suggested we use port 443 because EST, of course, is using TLS. And Ben said also the objective parts that are unknown must be ignored. CDP distribution must really use HTTP, not HTTPS, to avoid circular dependencies. And I also added a note why dual grasp isn't signaling the certificates because it's multicast. Certificates are large. That's bad. And that's just needed as a dependency for other stuff. There is a new section as part of the security review to talk in general about security association protocol requirements independent of what they are, especially important for somebody who writes a follow-up security profile with existing protocols or new protocols. So first of all, I think this is finally the right place to have the restatement that we don't need network-wide MTI because this is all hop by hop. We need to be able to signal the full certificates because we don't have other off-path options to learn about certificates. Protocols really love to have just, hashes or URLs signaled to be efficient by themselves. And all security associations must have equivalent degree of security to not create a weakest link because that's the obvious attack against an ACP. And that doesn't necessarily mean that we need to have strong crypto encryption at really the security association at layer 3, but there are at least, two common cases of exceptions. One is the one that we haven't done work for, that would be follow-up work, is if we have something like Wi-Fi MACsec or something that at layer 2 has very strong encryption, and at that point in time we would only need to figure out a secure association for the ACP that leverages that accordingly and also does ACP, authentication as a valid ACP member. And the other one, of course, is when we have strong physical security within a data center in the NOC. That's obviously what we've defined ACP Connect for, but this text also now gives some good reasons beyond the fact that you won't have strong physical security outside of those constrained places, but also that you can never do this auto-configuring fully, the strong physical security. That's something that really needs to be defined by policy, and that really makes it not really very useful in general. So this is just a workaround, really. Then there was a section about Ripple routing to unknown destinations, which basically is a function on the Ripple route to discover wrong traffic. And that was one of Ben Discuss's point. Otherwise, I thought it was very simple to resolve. So given how we're trying to have no new forwarding plane requirements, routes would have this requirement to have this diagnostic. So I wrote up a paragraph that says that, devices that can't have more intelligent functions like not being a registrar, not being able to have ACP Connect, and not allowing you to configure the route at all, those would be devices that don't have the requirement, because whenever those devices would become the actual root of a network, then all the more intelligent devices are already gone. And diagnostics isn't really possible anymore because the network can't be reached from the outside. So grasp via ACP Connect, there was a section in the appendix to say that we should have policy filtering, and during security review that was kind of misinterpreted to be a security requirement, was really only a service policy requirement. So I thought it's good, and I would still like it, but probably easier to have it in different text and not here. So I removed that. There was an interesting point about the ACP ANI configuration that was brought up, and where I figured that actually the explanation why we must configure in brownfield devices to enable the ANI as opposed to let it be default is really the case where somebody doesn't even know ANI is a feature on their routers. So that text was in there, but the real attack vector is a little bit more complicated, and I wrote this down, and that's really that if you don't even know there is ANI and what a massa is, your organization hasn't also not gotten any credentials to have registrars connected to the massa, and that typically makes it a lot easier for identity theft for people to basically claim, oh, I'm this organization, getting access to the massa, and then basically, of course, being able to attack you from really what the massa would consider valid certificates. So that's now in that text. So then, yeah, more text about ACP configuration as one of the, hopefully also very simple, you just configure one command and then you can attach in the NOC devices to it. That text was desired. I think I need to. Shift it likely. So then there's the section A8, which was talking about the general purpose way to negotiate across incompatible security associations more intelligently with something how do you negotiate between DTLS and IPsec if you do both and you have certain desires. So that was a very convoluted thing, and we decided already much earlier that that was too far out that we ever wanted to do this at this point in time. So I now put notes for the RFC editor in there so that it's not going to be included in publishment. I want to have all these far out thing at least in the last version of the draft, because when people go back and look at the history of the stuff, that makes it a lot easier, but that's gone. And finally, some diagnostics. So noting that the IDF ID may be more in security. So oops, I think I forgot to mention, what was it? So then basically Michael in January had provided really nice text to improve the way that the ACP addressing with the VLONG, where we have so many bits, gets expressed. So basically he introduced, just, there is no encoding change at all. It's just, this bit that decides whether this field is 8 or 16 long. He has given it, it's now a named bit in the thing, better text for that. And ultimately he also made a very nice picture showing comparison of the different addressing formats that we have. So thank you very much. So now let's get to the real core issues that we still need to resolve. So the first one is the encoding of the ACP domain information into the cert. It's currently a certificate RFC 822 name, which is a string. And so we encoded it in a human readable form that is RFC 822 compatible. Summarized, it's something like, ACP RFC number plus the ACP address plus some options at the ACP domain. And so there are a lot of reasons cited why we think this is a good thing. Backward compatibility, ease of coding, new ASN1. So especially I was, worried about that, whenever I'm doing diagnostics, even existing programs could show you the ACP address information without having to be revved up. So then Ben's discuss was that he was suggesting to use a new other name encoding point for the IANA and proposed a one-off binary encoding. So meaning no ASN1 structure. So my thinking, and that's what I sent back to him, and that's what I'd love to see more feedback from the working group as well. So I think we do always need a human readable NOC backend tool processable string as a standard representation. So why do we need two different standard presentations? And so something like local at domain is, common identifiers that humans understand for identities anyhow. Just our options part make it a little bit more, awkward. Michael.
Michael Richardson. So I didn't get any of this on the mailing list. You might want to start separate threads on issues like this. Mm-hmm. Otherwise, I just assume that you're dealing well with Ben's issues, and I can go on to.
Well, I did this last week and I sent it out yesterday. So we're talking here. So obviously, I'll bring it to the list. Yeah, of course not. No.
So I have implemented the RFC 22 name.
Mm-hmm.
There's some. The annoyances to it have nothing to do with encoding, but rather it turns out that your registrar has to allocate, because this certificate is produced during the enrollment time, and it's produced by providing CSR attributes as 7030 tells you to. So the new device, it's now enrolled, so it's not a pledge, does a get on CSR attributes. Emphasis on get, which is supposed to be idempotent, right? But you have to return the right CSR attributes in the with there. So you have to allocate the ACP address on an idempotent get, which means that you actually have to remember that you've allocated it for this device by its thing. And so that if it were to disconnect it and reconnect, it should get the same attributes again and everything would be happy. So that's actually the part that's kind of fragile and annoying. Figuring out how to encode it, completely irrelevant, okay? There are no libraries at all, IoT or otherwise, which return CSR attributes. I had to hand code it in ASN1, we're using ASN1 primitives regardless. So that part doesn't matter. You can pick anything you like, it's gonna be equally hard, even if it's RFC 22 name, equally hard in the CSR attribute side of things.
Right.
Okay. On the other side,
I'm just taking notes.
okay, on the other side of things, so then the CA has to then process the CSR, where yes, there are some issues with getting things in and out, but I would say they're not really a lot worse or better in my experience. But there are other CA software, which you are right, probably is much harder to change and much harder to update, particularly if it's outboarded. I don't know if you saw, I missed it yesterday morning, Kathleen Moriarty, are you in the room? No. So she has a document on ACME integration for the registrar. So the situation where the RA or the registrar is using ACME to get certificates from a CA, and what happens. RFC 822 name is completely supported and is a must for that, whereas other name kind of things are probably far less supported. Okay? So that's probably outside of our space of work. You can put a CSR for anything you like. It's just the ACME guy at the other end isn't going to deal with a specialized thing for us. So I think your argument is correct, that we need to stick with well-known stuff because that stuff is hard. As for the human readableness of it, none of it is particularly human readable. All of it requires an ASN1 decoder to see. So if you think about it that way, right? Yes, there are UIs that show you RFC 22 names, but they're not human readable. I can't read the certificate easily with the more command.
Can I ask here before you go on? Because my understanding was that because ASN1 BRDR is self-identifying, so it doesn't know it's a string, so it just prints the string as opposed to a hex representation.
This is true. This is true. But I'm saying is that it still becomes very, at that level it's very esoteric. If you're at that level of doing things, then it's you and me and 3 other people in the room doing it anyway. Okay, everyone else needs a piece of software to see the RFC 822 name as well as they would for any other name.
Well, I was actually looking at our, what in our pre-standard implementation, you have a whitelist, which is just the list of identifiers. Then you have the strings. They also nicely, whatever IPv6 address at my domain, right? So I think there are a lot of, operational processes where I think this really does get read by humans.
If I take a certificate and I base 64 decode it and dump it to my screen, not really advisable because there could be control codes and things, but if I do that, I will see the I will see a 22 name on my screen, and I will see other name in ASCII on my screen, both of them in the middle of a blob of garbage, right? Point is that equally well you can see them that way. To get anything more complicated than that, you need to have software that knows what's going on. And I'm saying it's probably as easy to do other name printing as it is RFC.
Well, but I'm talking about unchanged software, right? So I'm talking about their show certificate in pretty much all the places where I've dealt with certificates, and they basically deparse them to.
I you. I'm trying to say that I don't think it's that much worse anywhere else, but because of the fact that the CAs don't process things that they don't understand,
right.
They won't put things in they don't need, DNs and stuff that they don't know about, then it's hard to get them to change. That's the argument, not the human people. It's not
so, but wait a second. So you're saying that if I'm having a certificate, I'm trying to deparse, I see there is a new attribute of string type, I would still show it hexadecimal or not showing it at all? I mean,
not show it all. Or I would go unknown cert and dump something like this, because I haven't even been told to go beyond that point. So that's what happens if you do things like this. You get not things. In particular, a lot of the programs are intolerant of UTF and other stuff, and things like that. So all I'm saying is the argument isn't it's human readable. The argument is certification authorities are conservative in what they'll process, and it's hard. It's very hard to get them to do new things. So if your registrar does not have a built-in certificate authority, I think it's going to be the case for most people's code, then it's a problem. If you are coding a certificate authority, it's probably as easy to do RFC 822 name or other name anyway. They both require coding, especially on the CSR attribute side of things. Okay. So I'm saying you have the right solution, but the wrong argument. That's why you're having this.
Well, I think you're basically more with me on the using RFC 822 name than on the need of having a human readable string. That's fine. I'll take that feedback and bring it up with Ben.
Would the other name contain a binary?
No, a string, of course. I would keep the same. It would contain the same string, but we can now relax the string. That's my proposal, right? We can relax the string insofar as that we're not limited to 64 bytes on the local part when we start having more options, right? But I would keep the string because I like really the string encoding as making it really easy for human readability.
I think it will be easier for some people's IPsec or IP2 stacks to be able to put an RFC 822 name.
Okay.
So that's a space.
Okay, that's fine.
That is going to be.
That's fine.
So basically, build a connection to anybody that has anything at ACP domain.
Okay.
Will be a thing that people can do. Probably a lot of them will actually say allow a connection for anything that has a certificate from this CA.
Mm-hmm.
In which case the contents of the name will be.
So I'll try to summarize what you said also by the thread on the mailing list and go back to Ben and say that, I was making this proposal, but we're really in the group not really feeling safe to change from where we are right now. Okay.
I'm kind of hoping some other people might give me some opinions now, or someone about CA behavior or other things, but.
This is fine. We can take we'll take this to the list, obviously. So now the security profiles. So they're kind of so basically all the security profiles stuff have been improved and redone. So generic ACP certificate requirements, right, must be compliant with 5280, obviously. The minimum fields required are those required by the domain membership check. Anything beyond that is whatever the operator wants to use the certificate for in addition to the ACP membership check. And it would, for diagnostics, it would be lovely to copy the IDEF ID identifiers of a device, but of course it's a privacy risk. And then the stuff crypto. So the choices here now, I've tried to come up with something. So this is basically exactly for review. So obviously for this whole crypto stuff, I'll create another thread summarizing this. So must have an ECDH key, should be signed with ECDH key, and otherwise, if you can't still, old C8 not signed with ECDH, must be signed with RSA key. And the reason would be that ECDH is shorter in the certificate, and basically the more we go to longer keys, the more important this becomes. And of course, this implies that the secure channel protocols must be able to deal with these type of certificates. So now the question is, what crypto parameters on this, purely on the certificate side, are missing, right? So obviously the minimum signing length, whatever recommendation, people shout in the room, I'll take as default and then go with it. Or, asking Ben and the others. So basically there are some of these documents here where I'm going to reach out to other people that hopefully can give me more answer. There is somewhat of a complaint here, even though I have the no whining sticker here. I haven't really found a good RFC for, basic certificate requirements. And I found the good RFC for IETF2 requirements for interoperability, but even that says cryptographic recommendations for certificates are out of scope of the document PKIX community will do with it. So obviously you can't build interoperating IETF2 implementations if you don't have, interoperating certificates. So I'm wondering why they were able to lay out on that one without a reference.
So IETF2, of course, pointed at PKIX, which doesn't exist anymore. So,
yeah. Well, this is a 2017 document, right?
But it comes back to what I said. So certification authorities do what they do, and they do it with minimal kind of respect for what we tell them. Okay, unless you're a Mozilla person or a Google person and can read them and write act as to what you're going to support in your browser next week, they are doing what they do, which is 2048-bit RSA, which is, and then 256-bit ECD SA with the SecP 256. What is it, K or V1? I can never remember. That's what they do right now, right, in the web browser space. How do people produce interoperable IPsec implementations? Well, the majority of those are single vendor verticals, where you buy the XYZ Corp's remote access solution, and then you use XYZ Corp's certification authority, and
so my co-chair said we need to go faster. So I've basically taken down 248 for RSA and 256 for ECDSA with P256 as a recommendation.
I actually suggest that what you do is reference the CAB forum current requirements and suggest that they are the right answer, and that's it.
But that means, is it a resolvable reference that somebody can, okay?
Yeah, I'll point it to. I would say that's the best way, and it will solve the problem for that.
Okay, so then the IPsec stuff. So basically now the two references for the recommendations from end of 2017, 822.1 and 8247 are in there. Luckily I found them, nobody pointed me to them. So in IPsec, it's stripped down to just one security profile, which was chosen because it's the best performant one. We really don't need backward compatibility given how this is a new implementation. IETF2, no stripping down, it's just software. And we obviously can add more IoT profiles for those links later on because it's hop by hop, we don't need an MTI. So on the crypto side, in the signaling IETF2, we must use the full certificates because we need the ACP information. So that's PKCS7 REPT X509 certificate. Must have all the intermediate certs in the chain, and the proposed IPsec profile is AES GCM16. No null encryption, and obviously may support any more crypto profiles that are not of lower security. So now the question is what crypto parameters are missing from the specification. So and I'm going to reach out to the folks who wrote these two profiles to tell me if I was actually missing something. But GCMs should make things easier because it's self integrity checking. So no separate check needed. DTLS went through without anything. So that was surprisingly good. Then we've got as the final one TLS as used end-to-end within the ACP, and the normative reference for that is of course the use by GRASP itself, but any other protocol across the ACP that's newly built should obviously also use TLS. And there's obviously an interesting issue when we bring in IoT devices that don't want to do TCP, then we need to create more MTI, not only TLS, but server devices would need to support some secure CoAP in addition to TLS. So this is the ongoing discuss with Ben. What security profiles to demand? There, he basically recommended 3. I was thinking of the middle one, but then he was also saying that the nature of the RSA, EDCS, key size, elliptic curve. So basically there may be 1 or 2 parameters missing. So I hope I can resolve these things very quickly. And that was basically it.
Okay.
And that was just an hour over time? Something like that, yeah.
Something like that. Thanks. Any more questions? So we move to the next one, which is the ACP, GRASP API. Thank you.
And we want to do the grass API.
Yep. Okay, this will be much shorter, I hope. Next slide. Just a quick reminder what's in this document. It really is the, I guess that color is pink. It's the pink bit, the API for a functional library for calling the functions of the GRASP core from an autonomic service agent. Next. Contents of the draft, I'm not going to go through it because we've had this discussion before in a different room or possibly even in the same room, I don't know. It goes through design principles, some comments on asynchronous operations because GRASP is an asynchronous protocol. It talks about the parameters and data structures that are proposed for the API, and then it goes through the various functions describing the API for each function. And I remind you that this is an API spec. In the IETF, APIs tend to be informational documents, so it's not held to the same standard as a standards track document with all the musts and shoulds, because we know that implementations have to deal with the real world of their own operating system.
There's slight correction. Tabs, APIs are now standards track, so
Well,
we are evolving.
This is an evolution, but this is definitely not standards track. And it's not, of course, bound to an individual language.
Because right now you don't feel that
Yeah.
you would go as far as trying to do the same.
I don't think so, because I think we need experience. We need people to write APIs for various operating systems and languages and see if we can extract a standard practice from that. And of course, the way I designed this API, because I designed it, suits my programming style, and other people might want to do it differently. So I think we need to get something out into the field and then be prepared for feedback on it in a year or two. So next slide, please. That is the only question I have today, because I don't have any issues because I haven't received any comments for a long time, is are we ready to provoke people to look for issues by doing a working group last call?
But actually, before we could show hands, may I ask how many reviews you already received?
I haven't received a complete review from anybody, but it's one of the things you do in working group last call. There were comments at an earlier stage, and since then, we've responded to the comments and haven't received further comments, even despite asking the list for comments. So, either people don't think we should do this job, or we should try and provoke some reviews.
Let's go past the working group adoption call. So I assume people think that's a valuable work. But before we can really go for working group last call, I would like to get someone here in the room to do a review before we actually go for working group last call.
Sure, I'd be happy with that.
Anybody volunteer to do so?
I've already promised and not done it yet.
Okay, so you're promising again? Let the record show that Mr. Michael Richardson has promised.
Okay, make sure you write that down in the minutes this time.
And in particular, look at it as a C programmer, because I designed this with the viewpoint of a Python programmer, and it has been used by a master's student in Germany successfully. So apparently, it's not completely bogus, but it needs more checking.
Anybody else want here? I hope get at least 2. Come you do a review on this? Okay.
Action.
So hopefully we will see some review public in the mailing list in 1 or 2 months' time. Then, after you fixed the comments from them, we can go for working group last call.
Okay. That's okay. I don't want to have to come back to the next meeting and say the same thing. So that's the right time scale.
Yeah, I have this same wish. All right. Thank you. You want to do it, or I can do it?
No, I need to bring up the next slide anyhow first, and then you can ask that question. This Chromebus always stresses me out. That's not well. Which slide is it?
The next one. Yeah. Yeah, this is a report for the rechartering progress and give a little bit explanation on our potential new charter. Next page, please. Yeah, actually, we shoot down the rechartering long time ago. It was supposed to be 2 years at the very beginning, but it's normal IETF working group actually take around 3 years to do 2 years planning work. So we actually did that in 4 years' time, even longer. But that's where we get the very frustrating rechartering progress. We actually has earlier. Last, oh no. Yeah, this one. We actually start the proposed charter, new charter, around IETF 102, and many rounds discussing with the working group and also other people around. And we actually reached the convergence before the IETF 103rd, and we have submitted that to IESG review later last year, November. And since then, we have 8 update version already. And the latest one was proposed early this month, and it's supposed has clean all the discussing we have from IESG, our ADs. Actually, I believe we clean all the blocks this morning. So that's going well for IESG now, which I will show you later. And we are hopefully go for the external review and first go for IAB. And then later for the IETF mailing for wider comments. But that actually means we will not get our new charter in this month, maybe sometime next month. So even those drafts we had left in the new charter as milestone have to be wait. Actually 3 of them will present this today. And I would like to hear the working group opinion on them, but not official adopt on them. That adoption will come back on the menu is after we get our new charter.
Did we try to do adoption calls before already pending on the charter? I thought we did, at least for some of them.
We can do it again today. Yeah, 3 of them. Yeah.
As soon as the charter is approved, we had already done a working group call. Whether the working group wants to adopt, then I think we can simply pass them on. If not, we'll have to do another adoption call. And I think primarily also what, so Ignaz's notebook is still there, but his buddy went missing. I think what he would like to see immediately is that we put in the milestones for those 4 ones. And, while we removed it from the charter because people didn't like all too much process, what we were trying to do is, start with ones that we feel could be done within a year or 1 IETF more. So I think we're going to reach out to the authors and reconfirm that and then put the milestones in there accordingly.
Yeah, one of the major points we received during those discussing is the IETF, particularly the IESG, don't want us to, flood our working group, and we should guarantee whatever the working group adopted should be delivery as, a complete object in time. So that's it. Next page, please. Actually, there is a wiki. Everybody could check it, see what would be the latest one, and we're still open for refined suggestions. Next page.
I
think we need to change the number in the wiki to match really what is on the data tracker. Right now it's confusing, right? So on data tracker it's 207 and that represents 209. So I think it's right.
Yeah, they're in totally different numbering system.
So just keeping track of time, maybe I would skip reading through that.
Yeah, I planning to do that as well. So this is that what we put in for the primary milestone, and actually we pick up one from each area we identified for the working group. That doesn't mean we will only work on those drafts. That only means those drafts has a mature situation up to now to adopt first, and the chairs will manage the rest. Depends on how fast those drafts going out of the working group, because as we said, we don't want to either block our new work or get too little energy to complete the current working group work items. So today, I believe we will have the ESA guidance present in the morning, and the grasp distribution present this morning, and the constraint voucher already been working group document, and constraint joint proxy will be present this afternoon. And three of them we would like to hear how whether the working group supports the adoption, but we want adoption at this meeting. It has to wait for the new charter. Basically, that's it. Any questions, suggestions? Once, twice? Okay, let's move to the next. Oh, no, that's ours. I spoke to say.
Which one are we doing now?
Folk monitoring.
Yeah. Folk monitoring?
Yes.
No?
Yeah, I took it. Okay, can you make it like?
This is full. On the first one? Okay, yeah. Good.
And then the full.
This is already.
Okay. Thank you. So I'm Carlos Bernardo from UC3M. I had to ask the chairs, as they said, to move it up in the agenda because I have IP Wave to co-chair at 11:30. So apologies and thanks also for the other presenters. It will not take long, so I promise. So the idea of this draft is to present a use case that we have where we believe that the stuff that Anima is doing may be helpful for us. So I'm kind of new to Anima, so maybe there may be some assumptions from our side that are incorrect, so please don't be that on with me, but this is our idea was to see whether Anima can, or specifically, graphs, can be helpful for the use case that we have. So the motivation is basically we are working in several projects on what we call for computing. So basically it's virtualization pushed toward the edge, where we have like a very volatile environment. So it's not like a data center, because we may have resources on mobile phones, access points, base stations, cars, this kind of very heterogeneous and volatile environment. And on that, we are basically working on virtualization approaches and use cases that may benefit or use those resources in this very kind of dynamic environment. So we have some stuff in SFC, for example, and we are looking into kind of orchestration approaches that deal with this very dynamic environment. So let me see. Okay, so this is the one potential scenario that we are tackling in these projects. Basically, we have like different fog nodes, basically resources where we can put functions in like an SFC kind of way. And these functions, for example, we have a chain of F1 and F2, maybe running on on this fog node B and fog node A initially, for example, and then fog node A is moving away and we need to move the function that is running on fog node A, function 1, to a different resource, fog node C. So basically, this with current orchestration mechanisms is hard to do because it's very much reactive kind of thing, and we believe that we need some kind of more predictive things in order to be able to cope with this. So basically, we have what we call 4 resource information platforms, so something that allows to get more dynamic, more up-to-date events from the resources and to also be able to predict stuff and be able to trigger events. So, do you have a question?
Without my chair hat, I'm slightly concerned you use the forklift here because so far we don't have any definition or description what would be the forklift and where it should be in the network.
You mean the fog? What the fog? The fog orchestrator? You mean?
No, those nodes.
Okay.
I mean, what would be the forklift? What's the difference there from the endpoint user and where they are actually in the network, or they just sample of the end user?
Yeah, it may be an end user device. So, for example, the mobile. It may be a device in the network. It may be a device at the edge of the network, like an access point. So, I mean, in the draft there are more definitions about what we mean by a fog node, and maybe also references to. Well, I'm sure there are references to the projects where we are doing these things. But it's a generic concept. I agree that it's like resources going beyond the classical data center that will be kind of this thing, like in the cloud, and trying to have resources in devices that are in the very close environment of the end user device. That in this case may be a AGV, a drone, or something like that for this particular example.
So your actually means some end user nodes that has extra
resources, yes.
For other
users. Yeah. In the project we have, we are dealing with this kind of environments. Mobile phones, but maybe also cars or these kind of things. So it's research project, but we have like real use cases for cloud robotics and for drone control and these kind of things where we do this. And as part of this scenario, we believe that we need this kind of new orchestration solutions, more reactive, more proactive, let's say, not reactive. So for example, basically what we have is new monitoring framework based on 2 components, fog agents that are running on some or all of the fog nodes, basically responsible for sending information to a fog controller entity, which is the other entity that we foresee. And that fog controller entity, based on the information that it gets from the different nodes, may trigger an orchestration event. For example, migrating a function to a different node or scaling the resources that are associated or are allocated to one function, these kind of things. So this is basically kind of the overall scenario. Oops.
Which one do you want?
This one. Thank you. So we have the different nodes where we may have a beam talking about the HCNFV terminology. And in some of them, in this case, in all of them, we have this fog agent, and there will be a controller in the infrastructure. So basically what we want to use Anima for, Anima staff class in this case, is to basically bootstrap, discover all these fog agents, and make the connection or the association between these fog agents and the fog monitoring controller at the infrastructure. So this is basically what we are aiming at. I will not go into all the details, but we have some diagrams in the draft how these fog nodes may bootstrap, the fog agents may discover that there is a controller, they may exchange different information on the capabilities of these fog agents, and based on that we may have association between the controller and the fog agents. This is a simple scenario. There may be multiple controllers, there may be multiple associations. All these kind of things are at least introduced in the current version of the draft. So we try to analyze how we can use Grasp for this, and we already discussed mechanisms or this solution, the flow diagram before, using end discovery messages with new objectives and objectives options. Like, for example, we want to discover all the fog agents running on a particular type of fog node with a particular type of connectivity or with a particular type of resources, virtualization capabilities, these kind of things. And we also define different multicast scopes for the use of these discovery messages. So I don't want to consume more time. My goal was to basically introduce this use case that I guess is a bit different from what we have been discussing in Anima lately. And to see if there are people that may be potentially interested in this. We have already code for stuff based on the virtualization working, and we want to start doing things with using Grasp for this. This is not yet there. But if people are interested in this, please say that in the mailing list or contact me offline, and I will be very much happy to collaborate. I think this may be in the scope of the new charter in the future, like a potential use case to document. But I mean, at this point, what we really want to have is to see if there is anybody in the group that wants to work on this. So you have a question?
One question. Do you find the requirement of using Grasp over UDP to better suit for the very little fog node? Because Grasp, except for the discovery and flood messages, all the other messages are based on TCP. Normally, in IoT environment, TCP is not a very good protocol. And so,
well, this is something that we wanna investigate and we wanna try. So we have focused on the discovery part, and we believe that this may be useful. But this is good feedback to see and to understand, and we will need to implement the stuff and test and see how it works. But this is part of the ongoing exercise.
Brian Carpenter, the thing about UDP for the non-discovery and non-flooding parts of Grasp is that, you know, we hit the problem that UDP is an unreliable protocol, and there are two ways to fix that. One is to put the reliability into Grasp, which is a pretty horrible thing to do. And the other is to require that any operations using it would be basically doing idempotent operations. So if something fails, you just repeat it, which is quite a tight constraint on the application. So it's an area where we actually need some feedback before we do any work on it.
Thomas Eggert, just speaking as an individual to Lane to get up there. I'm very interested as an individual. I'll have to come to a conclusion about what I think about the working group later. I'd love to talk to you kind of just how it uses the ANI infrastructure, and to get back to the UDP stuff. If this is data that is being transferred, it can use Grasp encoding, but it doesn't have to use the secured environment, right? So it basically can be just over whatever forwarding plane exists in the network with UDP encoding or not, because Grasp all supports that. And the only secure stuff is what needs to be secured, and that goes through the ACP. So I think those are kind of the details which I think after we better understand what is the purpose of each particular traffic, does it need to be secure, so it could be added to that, and I think that would make it a lot more valuable as kind of an example reference use case or so for the working group.
Okay, thanks.
You go back one more slide.
This one?
Yeah. I mean, with my work group chair hat on, so far I'm not sure, how much this is for the reusable network management, or it's something purely in application layer. I guess you need to give me a little bit more detail on what you like to match here, and how that fit in the network, and what would be the reusable function for other stuff, like other application on those fog nodes.
Okay, so
we would like to see something, has the general use case and be able to benefit for the application or something above it, rather than do a very specific use case.
yeah, I think there are some additional details in the draft, but we can definitely work on on that and try to provide more stuff. Yeah, I mean, this was just starting draft to present this, but definitely there are many things that needs to be added there. So if basically I think that there are some people interested, so we can discuss offline, and then we will try to put more meat on the draft. Okay, thanks.
Bill Atwood, just to comment on what Torla said, maybe we should stop thinking about how little can we secure and thinking what do we absolutely not want to secure, and everything else is.
Information distributions.
Good morning. My name is Bin Liu. It's a quick update of the information distribution in automated network, which is mostly based on some extension to GRASP. Next, please. The previous one, thank you. Yeah, this is a brief reminder of what is the draft doing. We propose several functions which could be considered as infrastructure ASAS. Is actually still within the ANI scope. And the three functions are selective flooding, which is optimization to the current flood of GRASP. And the other two is a more sophisticated function to do the event queue messaging and distributed data storage. And in order to support the new functions, we need the GRASP to be extended. So we propose some update to add some new messages, the unsolicited synchronization and sub-pub new message. Next, please. So the main update since last IETF, we add a new subsection to discuss how to utilize the current GRASP API to allow the new defined functionalities to call the GRASP service. And fortunately, we found there was no necessity to extend the current API. So the API document could go as planned. Next, please. Yeah, there's some summary of the API utilized for the distribution models. The first one is a requirement of storing some data from a node. It just simply reuse the discovery message, but with some extension of the options to find whether there are some other node want to share some storage space for the specific purpose. And then if some nodes replies, the data will be transmitted by the synchronized calling of the GRASP. And if there's some publication information to all the nodes, the flood messages, the flood API is reused. Next, please. And the sub information is to for the submission of a specific type of information. We reuse the register objective API already defined, and also the flood message. And then if there's some new event or against the submission, then the synchronized will be again reused. Next, please. Yeah, that's basically the update. So for the graph distribution, the most sophisticated part is actually hidden within the modules rather than very sophisticated expansion to current either API or graph messages. So in standardization perspective, it is fairly easy, nothing very difficult to do. Okay, any question? Okay, then let's save some headroom.
So I'd like to ask the room who has read that work. 4, 5. Authors don't count at me. Right. But is there anybody else, willing to review this work? Because I think it's been around now for a couple of IETFs. It would be interesting to see if we can get more feedback. Thank you very much. Yeah, let's stick it with that. Thank you. Okay. So next on the list.
Yeah, I'll say it. This one is on our primary second charter, but we are not going to co-adoption here. We'll co-adoption on the mailing list after we get the new type upload.
Is it the guidelines or the scenarios?
Yeah.
The guidelines?
Right?
Yeah.
So I'd like you to imagine for a moment that the new charter has been approved. Because I think these are not new documents, but we haven't really put the question about working group adoption because we were waiting for the charter. So assume the charter gets approved in the coming hours. Next slide, please. Oh, no, wait a minute. There's news.
Just a comment about the timing. The blocks have been removed from the chat. So from IAG perspective, that is fine. But there's IAB which needs to also do an approval for that. So this is not going to happen today or tomorrow.
We had, while you were gone, we had the rechart and we're explaining that this, as you said, likely, in August, telechat.
Yeah. Anyway, this is just a reminder of what's in the drafts. I don't think there's much point in having substantive discussion until we can officially put them into the charter, put them into the milestones. This one still needs work. Nobody's saying that it's ready for publication or anything, but I believe that under the new charter, this would be very, very suitable candidate for adoption. So it still has the same contents as it did last time. Describes the logical structure of an autonomic service agent, how it interacts with the autonomic infrastructure, some comments on the design of GRASP objectives, because the information about that in the GRASP spec is intentionally quite limited. Then a discussion on the life cycle issues, since autonomic service agents are pieces of code that are very likely to be installed dynamically and updated dynamically on a working system. The problem that Laurent raised a long time ago, which may, of course, in the end is its own draft, I don't know, of coordination when you have autonomic service agents that are both interfering with the same bits of configuration, if you like. So you have to make sure that they don't fight each other. Those are the main topics. And, you know, the question I would ask hypothetically, since we can't ask it until the new charter is in place, is whether the working group is ready to adopt this work, which doesn't imply, of course, that you agree with what it says, but implies that you think the subject matter is something the working group should work on. So at this point, the question is how many people have actually read it? Yeah. I see a few hands. Yeah, yeah. We'd need a few more people to read it before we actually had the adoption discussion.
Yeah, but from the working group chair perspective, I'm slightly confused. Maybe that's a question to Lauren. Because earlier we agreed that we have another separate draft for the life cycle management. Is that still another draft, or because what we had in this draft, there is a section for the life cycle, but that's very short compared to a separate draft. So, do you still going to have that one for the life cycle management?
In fact, the point in the draft for the life cycle and coordination was just to highlight important aspect to consider in the guidelines, but not to go into all the details that will be covered by the potential draft on life cycle and coordination. So
yes,
we believe it's important that this is in this draft, but more as pointers to the other drafts.
Okay, so you still have the plan for the life cycle management draft, because that's another one we had in the primary milestone for the second charter.
For the second charter, yeah.
Yes. So we would like to see you working on that draft and bring that draft back next time, right?
Yes.
Okay.
Yeah. So clearly, if the life cycle and coordination material is covered in other drafts, we would have to adapt the text in this draft, you know, to not, you know, to not cause difficulties with the dedicated drafts. Yeah. But at the moment, we can't do that, of course, because there aren't any such drafts. Yeah. So anyway, I basically would encourage people to read this, because if we make a working group adoption call, it certainly helps if enough people have read it. Okay.
But I have to warn you that you actually create a dependency for this draft. Yeah, and that's your work. Also push Laurent to finish that new draft and also finish that. That's not new draft, and finish that in time. Otherwise, we'll have that misread again, which creates a problem for our working group for the last 2 years.
Yes, we clearly would like to avoid the same situation.
Yeah.
So, given the fact that life cycle and coordination drafts are expired for a long time, we have to discuss with Brian and other co-authors how to approach that. But I would suggest that we have a text that is non-binding to the draft, that just highlights those aspects that are important to consider in the guidelines. It can be self-contained, and then when the draft become new drafts on those topics, then there will be, taking those, what will be in this draft as starting points, not the other way around.
Yeah. Okay, so next slide. So this is another draft that's been around for a while. It's actually, I believe, a reference for the distribution draft that Bing just talked about. So this discusses use cases for bulk transfer in an autonomic network. Some of the use cases, there are probably others. It discusses a general method for doing bulk transfer inefficiently, I have to say. Intentionally, it's inefficient, if you like, using GRASP, because GRASP was not designed as a bulk transfer protocol. And it gives a worked out example of how to do it for an elementary file transfer. And it does make the point that if there is an existing bulk transfer mechanism, you know, that is more appropriate for an application, we could perfectly well use that within the ACP and get the security benefits of the ACP without having to artificially use GRASP for something that it's not good at. Richardson, sorry. Brain fade.
Richardson, you're not the first person to call me Richard. Almost failed high school because of it. As I recall, we invented this in order to distribute intent.
Yeah, we don't talk about intent.
And so maybe we should put this on the back burner until we have a use case like that argue for why we needed to do it.
And specifically, the question is why we need to do it and are happy to do it in a somewhat, inefficient way rather than using, a well-known file transfer protocol or file sharing protocol. I agree. I mean, I don't see any urgency in this, although I do actually use it when I want to transfer files on my desk between my Linux box and my Windows box. I do actually use this running code, and I use it because it's quicker than putting files somewhere else and bringing them back or whatever the other alternatives might be. So it works, but I agree. I don't think it's urgent. And if you're answering my question by saying not yet to the adoption question, I don't care about that. That's fine.
Yeah, that's also confused me. Why we do this work, because obviously your pros, the GRASP protocols can do such things, but I didn't say that necessarily it's for autonomic network to do that. And even so, I mean, there are other existing protocols can also do that work.
Yeah, exactly. But I could imagine a context where you might have where you're trying to minimize the amount of software you have to load in your target system. And this might be a cheaper way, of achieving low urgency bulk transfer than a cheaper way in terms of footprint, right? So I wouldn't say we should exclude it as a use case, but I agree it's certainly not important to push it too fast.
Yeah, I mean, if you want to bring this work back next time, we would like to see something, something can give us a must use case in the autonomic network, right?
Yeah. I don't think at the moment, I don't think there is a must use case. I just think it's a pragmatic question. If it turned out to be better than, sticking an FTP code in your tiny device. Yeah.
That could also be the case.
Yeah.
But, I mean, next time we need more solid support why we did that work in autonomic network.
Yep.
Right?
That's fine.
Thank you.
I'm not next again, am I?
Yeah. Well,
oh yeah, because you swapped them around. Yeah.
Is this you?
Yep, that's me. Yes. Okay, so this is something completely different. Definitely probably not possible under the old charter. And it was intended to present it last time and you ran out of time. And I wasn't here anyway. Bing was going to present it. So next slide, please. So this draft talks about scenarios where you might want to build your ACP as a layer 2 construct, and then tries to get to some preliminary ideas about requirements for doing that. So next slide, please. So the rule, of course, is that GRASP doesn't have its intrinsic security, so it must run over a secure ACP substrate, which should be isolated from the normal user data plane traffic. And we had a very, very, very long argument with Eric Kriskula before we got GRASP through the ISG. And that basically was a very strong must in the document that resulted. Now, the regular ACP constructed at layer 3 is complex, and I don't think that even Turles would disagree with that statement. And it's aimed at large networks, since clearly we're not going to do things like running Ripple over and building a complete VRF environment and so on, except in a reasonably complex large network. So we think there are scenarios where a layer 2 solution could be used. For example, a small enterprise, which is all in one building or spread across a couple of buildings, but it's large enough that they want an autonomic network, probably because they don't want to pay a crew of geeks to run their network. They'd rather the network run itself. Or an enterprise which prefers to segment its network into small units for management. And there are a lot of enterprise networks that do that, because it's the simplest way to think about security is to have lots of little pieces and keep each one secure. If you decided to do that, you might prefer to build your ACP locally on each of those pieces of the network. So next, please. So let's assume you've made that decision that you want to build your ACP at layer 2. Then the draft goes through, of course, with some arguments about each of these requirements. Some of them are fairly obvious. It needs to support transmission of IPv6 packets. It doesn't actually, on a single L2 segment, need to be running any IPv6 routing. On a single layer 2 segment, GRASP will run perfectly happily with only linked local addresses available. So you could imagine a scenario where you had a self-contained autonomic network running entirely on linked local addresses. And of course, there'd be some sort of interface to the network management center, which would be across a routable part of the network. It must support L2 multicast. That's a fundamental requirement which we built into the design of GRASP, which may have been a mistake, but that's what it is. Minimum MTU of 1500, that's sort of fairly obvious. There's one little awkward thing there, that we defined the maximum GRASP message size as 2048, which doesn't fit into 1500, right? But it's possible we'd also have to add a constraint on the deployment of GRASP that it also would fit inside 1500 byte packets, which for a lot of the things we expect people would use GRASP for, it isn't a problem. You need a technology to isolate a set of nodes, which is the ACP VLAN, basically. So this is a fairly obvious way to do this. It would be VLAN technology, secure VLAN. And you need to make sure that access to the ACP VLAN is authorized in a secure way, so people can't just plug into it. As far as I understand VLANs, that's almost a proprietary requirement because there doesn't seem to be a very general solution to that problem, but maybe somebody can correct me.
Xing as an individual, I'm very concerned why you have here for the IPv6 transmission as a must, because what the benefit I can think of if we are going to do such layer 2 ACP is to be able to use it in other scenarios rather than the IPv6 network.
Well,
before, but you put that as a must.
It actually isn't a very difficult requirement. because it's not a requirement on the network except for the support of multicast, which it doesn't need to because it's level 2 multicast. Right? I mean, you're not saying there are any you don't tell people they have to buy an IPv6 router for this. They just have to have a piece of wire or virtual wire which is capable of carrying IPv6 packets. That's not actually a requirement that is hard to meet.
No, the point is if we have such scenario for the IoT network, which has very constrained resource on the nodes, that requirement here for IPv6 packet transmission actually requires a lot, for protocol stack.
Yeah, this is a requirement on the nodes. That's correct. It's not what I'm saying, it's not a requirement on the network, it's a requirement on the nodes that they can transmit. Yeah.
Exactly. So that actually, what I suggest here is if we are going to do such layer 2 SAP, if we could remove the dependency on IPv6, that would be much better.
Yeah. I hope. Sorry? I can't remember. Do I have more slides?
Well, I mean, for somebody who hasn't read the draft, I don't think at this point in time it would be clear what you're actually proposing.
Yeah. Okay, let me, if you can hold on, I think we're nearly there. Then it turns out when you continue with the requirements, there's some shoulds. You'd need the data plane VLAN and the ACP VLAN to be on the same physical socket, which sounds like a silly thing to require, but I think there are some implementations where you can only put one VLAN on a given piece of wire.
Do you mean BSD socket?
No. Physical connectors. You know, when my readings about VLAN technologies, there seem to be cases where you can only allocate a given socket to a single VLAN, whereas it should be able to support more than one. You would like to have line speed encryption of the VLAN, but that's really a local security decision whether you pay for line speed encryption, and you need wide wireless bridging if relevant. Show me the next slide. I think it's the last one. No, it's not. No, you can go back. The one thing I couldn't figure out how we could do is to avoid some degree of configuration of the nodes in order to pre-configure the VLAN ID and possibly a password or encryption key for access to the VLAN. You know, this isn't a solution that would self-configure itself 100%, where you just unpack the boxes and connect them and magic would happen. You would definitely have to do some degree of configuration to put the VLAN in place. So I'd like to go back to Sheng's point, those if you go back 2 slides. Yeah, we said at a fairly early stage of the development of GRASP that we were only going to define it for IPv6. The big difference between IPv6 and IPv4 is going to be the fact that the concept of a linked local address, although it does exist, it was retrofitted to IPv4. It's not as well defined and nicely defined as it is for IPv6. So I haven't actually thought about this very deeply. I think you would run into one problem if you were trying to operate the GRASP relaying mechanisms where discoveries and floods are replicated on a different interface when they come in on one interface and they have to go out on another interface. If you don't have that in your topology, right? In other words, if you do have a single layer 2 topology, then I think the IPv4 link local stuff would work perfectly well, and you could be completely independent of the regular data plane IPv4 addressing mechanism.
Can I interrupt there and ask, if I kind of deduced correctly what you're trying to do anyhow? Because I think there was no explanation what the planned solution is. The planned solution seems to be you're building the ACP by, auto-negotiating across an existing bridge layer 2 domain, a separate VLAN for the ACP. Is that kind of a good summary?
I think that's how it would come out, yes. Yeah.
That wasn't said.
Yeah. And in that case, you could, I think you could translate the concepts back to IPv4. Yeah.
Right. I think, we through the work on the original ACP, we went through a bunch of these investigations, and I think one of the interesting questions is just what you use for the layer 2 discovery of neighbors.
Yep.
On that, which obviously cannot be tagged, and then you probably also don't want to do something that uses existing discovery protocols like LDP or CDP because they may be blocked.
Yeah. So
you basically need a layer 2 allocation, do your discovery, which could be layer 2 grasp, negotiate a VLAN, and wonderful. I think it's not that difficult, and these details here are fine as far as having the points of consideration for them.
Yeah.
But I agree to all of them is a different point. But
yeah, of course. Yeah, this is a 0-0 draft, if I'm not mistaken. So
actually, this discussion made me, miss myself between the individual and the working group chair. As individual, I think we should make it IP independent, neither IPv4 or IPv6. I would like to say it's a pure layer 2 solution as an individual. But as a ANIMA working group chair, as far as I remember, we have the IPv6 in our primary charter. I mean, the first stage charter say we should do something based on IPv6.
Well,
I'm not sure. I think we don't have such a restriction on the new charter, but still, I'm not sure. As working group, we could work on the layer 2.
No, I mean that's well, my opinion about charters is if they're wrong, change them.
Hi, Michael Richardson. I'm not going to talk about the V4. It's old, dead. But did a lot of research about the AC when we were talking about ACP on MACsec. So it is an IEEE protocol. When I first looked through it, they did not seem to have a key management protocol. That is not true anymore. But the proposal initially that I had was that we would write, because we're running in the ACP, we're running IKE over link local v6 addresses, okay? That we would propose, instead of ESP, we would propose MACsec as another option, and that we would key it that way, and that it would be effectively transparent. Some links might be MACsec and some not. As far as I remember about MACsec, it is point to point, okay? That's right. Per link, not per VLAN. So you actually have to put all of your traffic, including your data plane traffic, on that link through that channel. Not necessarily the multiple key options. But it could be encrypted differently. But the point is that everything that goes out that port has to be encrypted.
Obviously, also the protocols that are setting up the encryption are not encrypted.
So the point is that we could get, is what I'm hearing then from you telling me, is that we could have, by whether we use the IEEE key management algorithm or IETF2. The point is that we would wind up negotiating a point-to-point set of tunnels, one of which VLANs could be the ACP. The other ones would be for the system. But that what we would need is the additional tag is the VLAN tag.
Yeah.
Okay. And I understand it that it's all designed in line cards to run at their line speed, and that they're all very happy about that. But from my point of view, I don't think we need any more discovery. I think that we can do it all. The only question is to what extent. I don't know very much about the IEEE's key management protocol. I do know it does take certificates, and we have certificates. Okay, so the only real question is, you know, we might want to put something, for instance, define a IETF2 attribute that says, oh, by the way, I could have done MaxSec. At which point you might go, hey, well, actually, let's start again with MaxSec's key management system, and we'll abandon the IETF2. Okay, that may be the right answer, but given that you have to encrypt all the traffic, that may not be something that everyone wants to do in every situation. So maybe there are advantages to not doing it that way. But I think in particular, you should say is that you have this bridge layer 2, you know, scenario. The bridge mechanisms are not participating in the ACP. They are invisible things. They may even be provided by another party, and they may be untrustworthy from that point of view.
Which I think is also the answer to Sheng's problem about, are we allowed to do it in this working group? Because we're not doing the L2 stuff, we're just using the L2 stuff.
Right. So, Thomas Eckert, from just the perspective that the ACP itself, of course, defines right now how you can do ACP across a network that by itself on the data plane is just a layer 2 network, like instead of, you know, layer 2 bridges and building just the normal ACP across it. And whether you do that or not, obviously the ability of the existing ACP mechanisms to negotiate between neighbors, something like MaxSec, was something that I mentioned in my slides initially, something we haven't done, but which could be nicely derived out of what we're already doing. So if it only comes to supporting layer 2 bridge networks with existing ACP, I think we're in good shape, and I'm a big fan of MaxSec, so definitely trying to define an ACP security as channel association using MaxSec to me would be just a matter of finding the cycles to do that and trying to find help for that, right? So as Michael said, the key difference I think here would be to relying on a pre-established layer 2 bridging domain, which by itself is insecure and can break, right? Because on the existing solution of the ACP, the big benefit is you don't rely on the existing bridging stuff to work. The ACP will work even if your bridging breaks. And in this case, in your solution would be simpler, so to speak, but if the bridging breaks, the ACP also breaks.
Sure.
Right? So I think those are kind of the differences I think could be put in there. And then, yes, I think one of the things that we might want to look into is that this whole thing, you know, auto-negotiating a layer 2 VLAN and then trying to figure out how to secure that layer 2 VLAN is a lot more around layer 2. So maybe, you know, catch up with somebody like Norm Finn. There are a few layer 2 experts here and brainstorm. And maybe that gives us a better way on how to scope this.
Sure.
Ms. Bogdanas is speaking as a working group member here in this context. So you have some things in your document which don't necessarily align with the operational reality or practices.
This is entirely possible.
The section about the native VLAN. The use of native VLAN is discouraged. And one of the practices is to move it away from identifier 1 and shut down. That's just a commonly accepted practice. Now, the other thing is reading the document, at least I make an assumption that, impression that there is an assumption that if it looks like an Ethernet cable, that means it's transparent bidirectional, and what you put on one end, you receive on the other end. That's not necessarily true. And even if we're talking for the deployments which are positioning into enterprise side, a common trend, and that is increasing, that what looks Ethernet as a service is implemented on top of some other packet substrate. So if you see that it's a layer 2 Ethernet connection from point A to point B, it very well might be that it is implemented on some other packet infrastructure. And you have severe restrictions of what tag values you can use. It cannot be assumed that it will be bidirectional. It cannot be assumed that you will be able to send multi-destination frames in the same way as you can send single destination frames. So it's basically about the point 2. If you can avoid layer 2 multicast, please do. It's evil. It's evil from an operational point of view. It's painful.
Yeah, I'm quite aware of that. Well, I assure you, I'm a veteran. I'm a veteran of multicast storms from many years ago. But it's actually very hard to avoid it because of the way the IETF has developed its protocols over the last 30 years or so. But is there a reference? Is there somebody who's actually written up this set of difficulties?
There is one document related to the wireless environment, basically .11 Ethernet, which talks about the evils of multicast in those.
Oh yeah. I'm very much aware of that.
I don't think that includes discovery, just anything beyond that.
Yeah.
Yes.
Yeah.
So one other comment, maybe you should look into .1x. And that might address some of the requirements for securely connecting to the layer 2 network. Because you have one section in the document which talks about password protected access to the VLAN, which reminds me the MPS horrors 20 years ago, and I'm really happy that has gone and forgotten.
I didn't.
Please don't bring those back. And also requiring password authentication for something will certainly raise interesting looks from a security.
Yeah. No, as far as I could tell, there's a lot of variation in the way that proprietary layer 2 stuff does this. So I could.
.1x is not necessary to proprietary.
There are
extensions to that, but the core of the functionality is interoperable.
Yeah.
And that might be a good starting point.
Yeah, if we wanted to make a recommendation, that would be an obvious one to make. I agree. But the stage we're at in this document, it seemed too soon to say that. By the way, there is at least one more slide somewhere. Yeah, we're nearly finished. That's the one. Yeah, hold on. Bing, my co-author.
Yeah, speaking as the co-author. And my perception of the discussion of dependence of IPv6 is that maybe rather than saying IPv6 is a must, maybe it might be more precise to say what we really need is something that can provide autonomous L2 connectivity and transmission of packets that could be secured and separated from a normal L2 data plane. Yeah, that might be more precise. And for IPv4, maybe it's difficult without pre-install of some private IPv4 addresses. But with pure L2 solution, Michael just mentioned MACsec. We don't have a clear answer yet, but I think maybe there's some way out other than IPv6.
Yeah. This final slide, it's probably hardly worth discussing, but one thing we need to do in the engineering of this is to make sure that the upper layer, which is GRASP, and the lower layer, which is the ACP, talk to each other in a reasonably standardized way so that, we have ACP code that will work under GRASP, and we have GRASP code that will work over ACP, regardless of what choices are made on the two sides of that boundary. And
Mike Richardson says, so this slide suggests to me that you believe that the entire ACP will be over a layer 2, and that you will not need a routing protocol.
That was the thesis, that this would be done in smallish segments.
But based upon the statement that MACsec is a point-to-point system, let me suggest you're going to need a routing protocol because you're going to have a bunch of point-to-point links.
Well,
right, as Ignace said, you may not be able to send, multicasted things. So
multicast is the problem.
There may be two separate things, and I don't think the issue of what are the addresses is the issue that you have. The issue is what is your topology, and we actually know what the we know what addresses we've allocated to what ULAs we've allocated within the thing because they're in the certificates. So it's not really the issue. The issue is how do you find the adjacencies that you need?
Sure, but that's not an ANIMA problem, by the way. That's a problem everybody has who.
Right, but we solved it with Ripple.
Oh yeah, I'm quite
there. So you're really just suggesting that you're going to replace that part as well.
No, not necessarily. Maybe we would keep the Ripple part of the current ACP.
Then the multicast problem becomes a GRASP problem, which
Yeah.
it was already.
Yep.
Right.
I mean, there are just a lot of different components that we can plug together differently, right? So the one piece that we currently don't have is trying to figure out for the ACP a different VLAN on interfaces where we also have the data plane. So right now, basically, the ACP is just using the same IPv6 loopback addresses that are used in the data plane. So that basically creates a dependency against the data plane that's noted in the ACP document. That's one of the things I wouldn't like in general, because it makes it very hard to isolate, in implementation and everything. So discovery of a VLAN for an ACP, I think, is a very generic function that I'd like to have. Then the next thing is, what type of ACP are we building across it? Is it just the normal ACP that we're doing right now, or would it be something different, right? So maybe that's one piece to start from the bottom up with one component that we need, whether we do this or not, and then go from there.
Okay, I think there's a last slide that asks a question. Right, the question, we've had comments and questions, and we're close to the time limit. So I think the real question is whether this is work that's interesting enough that we should go on doing it, or should we just forget about it?
So Ignas Bogdanas, so the question, I think the main question that the working group needs to answer, what is the problem that we're trying to solve with this? What cannot be done with other components that we already have?
Yeah, so in my mind, the ACP that you are currently pushing very hard through the IESG is very complex, right? And the idea here, which perhaps wasn't stated clearly enough at the beginning, is to try and have something simpler for simpler scenarios. If we can't make it simpler, then there's no point making it at all. Yeah, that's.
Looking into some history with with routing protocols which run on non-IP transport. One of the big areas of a complexity there is actually implementing what IP transport and high layer transport protocols can give you. So basically, spacing, fragmentation if needed, and things like reliable transmission and things like that. Don't you believe that it might be such a case that if you remove some complexity on ACP itself, but in order for that functionality to work, you will need to add complexity or basically invent a lower transport layer for this lightweight ACP?
I didn't say lightweight, but yeah, I mean, it's possible that the question is really whether we should continue to explore this, or whether we should just
maybe really start laying out the different scenarios. So I think I talked about the scenario of just having a secure VLAN discovery mechanism, agreement mechanism. The second one is what are the pieces when we want to set up we want to set up a cross-abridged VLAN MACsec, which is hop by hop. Maybe that's basically exactly the use case where this ACP comes in as the way to do it, right? And the third one is, can we basically have the signaling within, that VLAN stuff simpler than the hop by one, and we have something, I can see something like 3 scenarios to work through and come to conclusions with.
Yep. Okay.
All right. Okay, I guess that's it.
Yep.
Yeah. So that take us 1 minute before 12, so very good timing. And we have another ANIMA session just the second 1.5. That one will be breast key relevant stuff dedicated. Right. Thank you. See you afternoon.
It will be a lot more exciting in the afternoon. Come all day.
So we should like eat a good lunch.
The working group chairs lunches tomorrow.